Okay. We have a rational inequality here. X might, no, here it is. Okay. So rational expression, we want to know where it's greater than 0. And really the way we do that, well, you can graph the thing, see where the graph is above the axis, where it's below the axis. So then you can tell where it's positive, where it's negative. A quicker way to do that is to understand that, well, the way I say it, not quite the way the textbook you're using says it. But if the numerator is 0, well, the only way this thing can change its sign, the only place this thing can change its sign is between zeros of the numerator and zeros of the denominator. Okay, so you look for zeros in the numerator and denominator. Well, it should be obvious that if x is 2, the numerator is going to be 0. If x is -3, the denominator will be 0. If x is 4, the denominator will be 0. So it's real easy to find the zeros. You just set the, once it's factored, you set the factors equal to 0. Okay, so this divides the x-axis. Okay, at x equals 2, let's just say 2 is here. Then at x equals 4, 4 is here. And at x equals -3, let's just say -3 is here. Okay. Now, to the left of x equals -3, well, x is going to be less than -3, right? If x is less than -3, then x plus 3 is going to be negative, right? So is x minus 4, because you have 2 negatives. And so is x minus 2, because -3 minus 2 would be negative, okay? So to the left of x minus 3, all 3 factors, this factor, this factor, and this factor, doesn't matter whether it's a factor of the numerator or denominator. If all 3 of those are negative, then you've got 3 negatives being multiplied and divided. Well, 3 negatives is going to give you a negative. Okay. So 3 negative factors imply that expression is negative. Okay. So all I'm going to ask you to do is just tell me between -3 and 2 on this end, which factors are positive, which factors are negative. Now, the easy thing is, whether any one of these factors is positive or negative, the answer is going to be the same all the way between -3 and 2. Okay. So really, you only have to pick one number between -3 and 2. See which is positive, which is negative. Okay. See how many positives, how many negatives, and then you can conclude whether it's positive or negative. Of course, if it's positive, it's greater than 0. If it's negative, it's less than 0. So if you can identify the intervals where it's positive, where this whole thing is positive, you got your solution. So let's just do it one step at a time. Okay, check out this interval. Then check out this interval and check out this interval. Okay, so what I ask people to do is plug in some numbers between -3 and 2 and see what you get. Okay, well, what you got every time this number and this number were both negative. And every time this number was always positive. Okay. So let's just look at how that works. For example, okay, well, I did an example here for numbers to the left of -3, but over here, I did numbers between -3 and 2. Okay, so every x between -3 and -2, I'm asserting that this has to have the same sign. And this is just this, it's a little better over here, okay? This expression has the same sign because the only way it can change sign is if x crosses -3 or crosses 2. And between -3 and 2, they all have the same sign because between -3 and -2, there's no place where this is equal to 0. It can't change sign except by going through 0, okay? Or having a vertical asymptote where the denominator is 0, okay? Because the denominator is 0, it can change sign. Can't change sign unless the numerator is 0 or denominator is 0. So here, the denominator is 0, here the numerator is 0. Those are the only places between -infinity and here where the thing can change sign, okay? Well, that's a theory. Practically, you can see it. I just let x equal 1. So if x equals 1, you can verify the arithmetic. We get a negative here, we get a negative here, and we get a positive here. Since we got two negatives and a positive, multiplying and dividing, two negatives give you a positive. Okay, so clearly positive, okay? Because the two negatives make it positive. Okay, if x is -1, well, same thing, and you've already done it for other numbers. You got to get -3 here, -5 here, two negatives and a positive. It's always going to happen, any number between here and here, and you might think about why. It's because any number between here and here is bigger than -3. So x plus 3 is going to have to be positive. Any number bigger than -3 is going to make this positive. And any number less than 2 is going to make both of these numbers negative. If x is less than 2, x minus 2 is going to be negative. In order to make x minus 2 positive, x has to be bigger than 2. Okay? Now, of course, to make x minus 4 positive, x would have to be bigger than 4. And of course, that's not going to happen between -3 and 2. So if you understand all that, then you understand why this works. Whether or not you do, you have a rule that says plug any number between two consecutive zeros of the numerator or denominator, and that'll test the interval. And the answer will be the same for every other number in there. So you only really have to test one number. Now, the first number you plugged in was 0. Well, that's really easy. And you got a positive. That's enough. That tells you all on this whole interval is positive. Okay. Now, the way I do this, and you don't have to do it this way, but the way I would indicate this is on this interval from here and here, you have a negative divided by a positive and a negative. In other words, this is negative, this is positive, this is negative. It's true for x equals 0. It has to be true everywhere. Check it for a couple more numbers to convince yourself what you did. So I think you might be halfway convinced that it's true here. Okay? Well, do the same thing now for the interval from 2 to 4. You only have to pick one number in that interval. Now, you can't pick 2 and you can't pick 4 because that would just give you 0, right? And then think about the interval from 4 to infinity. Okay. Well, from the fact that, if you believe me, since this is negative, and this is positive for one number between -3 and 2. It's got to be positive for every number between -3 and 2. Okay. Now, on the interval from 2 to 4, now I think some people wanted to plug in 4. You can't plug in these numbers because they're always going to either give you 0 or an undefined result, which doesn't help you in determining whether this is greater than 0. It's got to be a number between here and here. So if we do a number between here and here, well, between 2 and 4, the sign can't change. Okay. So we test x equals 3. Okay, we get you get 1/6 times -1 if we plug in x equals 3. This is clearly negative. You don't have to do any more arithmetic. All you got to do is look at the signs. 2 positives and a negative are going to give you negative. Okay. This is clearly negative. Okay. It's clearly negative, so we can conclude that the same is going to happen no matter what number you use between 2 and 3. Whatever number you choose between 2 and 3, the numerator is going to be positive. The denominator is going to be a positive times a negative. You're going to get the same signs. You get different numbers here, but the signs are always going to be the same. Again, it's useful to think out why. But whether you understand why or not completely, it works. Okay. So we conclude that between x equals 2 and x equals 3, x minus 2 over x plus 3 times x minus 4 is negative. Okay. So we get positive over positive times the negative. Always negative on this interval between here and here. Okay. Now, from 4 to infinity, you can't have any more sign changes because none of these factors is going to be 0. Okay. So pick a number greater than 4. Plug it in and see whether you get a positive or negative. Okay, so we plug in 10. People chose to plug in 10. So I was complete. Was completing. Move here. Interval x greater than 4. There's no way to change the sign. See, You chose to test x equals 10. Okay, 10's a good choice. It's a round number. It's easy to work with, right? 5 wouldn't have been a bad choice. 13 wouldn't have been a bad choice. Any number greater than 0. 794, well, you get an obvious result, okay? If x is 794, 794 minus 2, is that positive or negative? Well, obviously it's positive, okay? 794 plus 3, obviously positive. 794 minus 4, obviously positive. It's so big that the minus or the plus down here, small number, isn't going to make any difference. You could have chosen 10 trillion. If x is 10 trillion, all you got to do is say, well, 10 trillion minus 2 is still positive. You know, if I had $10 trillion and lost 2 of them, I still have a lot of money. Okay. X plus 3, x minus 4, same thing. If I have $10 trillion and make $3 today, it doesn't make much difference, does it? Okay. Well, nobody has $10 trillion. Some people are sneaking up on $1 trillion. Take Elon Musk these days. He's about a quarter of the way to $1 trillion. Okay. I haven't talked to him today, so I don't know. He usually calls me and tells me. Okay. So x equals 10. 10's a good choice. $1 trillion is even a better choice because you don't even have to think about it. It's all positive, right? But x equals 10 is fine because then you really see how that works too. So, yeah, 10 minus 2 over 10 plus 3 times 10 minus 4. Well, 10 is not $1 trillion, but it's big enough that all these are going to be positive. Anything bigger than 4 is big enough that they're all going to be positive. Because if x is bigger than 4, you subtract 2 from a number bigger than 4, it's going to be positive. Subtract 4 from a number bigger than 4, it's going to be positive. Add 3 to something bigger than 4, well, add 3 to any positive number, it's positive, right? So there are lots of ways to think about it, okay? Now, it's a little redundant to calculate or a little unnecessary, but why not? They're all positive. So if x is bigger than 4, it's positive, right? Okay, so over here you get a positive over a positive times a positive, which is positive, I'll just say it's greater than 0. Okay. Over here, this is positive. Any minus over a plus times a minus is positive, right? Over here, this is negative. And over here, I didn't write it out, but you got negative over negative times negative, which is negative. So now we understand that this thing is negative all the way to the left of -3. It's positive here. It's negative here. It's positive here. Okay. So our solution, our payoff, I'm doing a lot of ordering over here, so I'll just kind of write the result of all this reasoning. I think I can write solution set, okay? Consisting of the interval -3, 2, union with the interval 4, infinity. Is that notation familiar? Well, that's exactly what it says. There's the interval -3, 2. So this interval is good. And this interval for infinity is okay. So your rule is just divide the x-axis up into intervals according to where the zeros of the numerator and denominator are. Doesn't matter if it's a zero of the numerator or denominator. Divide it up. Okay, then test each interval. And hopefully understand why that works. Because if you understand why it works, you're going to be more likely to execute it correctly. Okay. The bottom line, if you know the rule and apply it, it's probably going to get you by, unless your instructor's asking for explanations. Okay. Then if you're being asked for explanations, well, you ought to be able to explain it. Okay. Not much more to it, but let's go ahead and ask you to test this. What if it's x minus 2 squared over x plus 3 times x minus 4? Do the same test, divide it up into intervals, and see what happens. Okay, so main test of slight change of this function. I squared the x minus 2, so let's do the same test. Okay, again, on the x minus 2 squared equals 0, right? Now you can just see that if x is 2, that's going to be 0, right? That's going to be very easy, but in general, you might have to do a little bit of algebra. Okay. So to solve this, we'd say, okay, so if x minus 2 squared is 0, that means that x minus 2 is plus or minus the square root of 0. Which means that x minus 2 equals 0, because plus or minus, well, the square root of 0 is 0, right? So x equals 2. So if you had to do a little algebra, you'd follow the rules of algebra. You'd set your numerator equal to 0 and do whatever's required, right? In this case, though, we can just see that it's going to happen at x equals 2. Still, it's worth reviewing how we do this. Denominator 0 means x plus 3 times x minus 4 is 0. So x plus 3 is 0 or x minus 4 is 0. So x equals -3 or x equals 4. Again, many times you just look at these and see. But in general, you want to write out the equation, this equals 0, and the equation, this denominator equals 0, and solve. So now we get the intervals -3, but we get the points -3, 2, and 4. Sign changes only at these points. Okay. It doesn't have to change at any of these points. But the only way it can change is at these points. It might or might not change. We'll see. to follow the process it'll tell us. Well, we have three intervals. Negative infinity, -3. Interval -3, 2. Interval 2, 4. Interval 4, infinity. On some combination of these intervals, you're going to have this, and I didn't write down the equation. You know, just for contrast, you're going to solve for less than 0. Okay, equally easy. Once you have these values, test this interval, we'll use x equals -10. And you get a negative squared. Okay, well, let's write it out. You get -10 minus 2 squared over -10 plus 3, -10 minus 4 equals -12 squared over -7 times -14. This is positive because you square any number, you're going to get a positive, right? Over a negative times a negative equals positive, right? So this thing is greater than 0 on this interval, so this interval is not part of your solution. Now, test -3, 2. X equals 0 is always convenient. One of your intervals, unless one of your zeros happens at x equals 0, one of your intervals will contain 0, and you probably want to use 0 because that's an easy number to substitute. You get 0 minus 2 squared over 0 plus 3 times 0 plus 4. Any square is positive over positive, positive. And that's positive, right? So here we get so that on this interval, wait a minute, I've got something wrong. It's going to be negative in this interval. It's 0 minus 4, right? So that makes it negative. Positive over positive, negative, which is negative. Okay. So this interval is part of your solution. Well, let's go into this interval. You get 3 minus 2 squared over 3 plus 3 times 3 minus 4, right? Well, that equals Numerators again positive over a positive times a negative. Okay. So in this interval, you get a positive over positive times negative, which is negative. So on this interval, as well as this interval, you didn't have a change when x equals 2. Okay. Now there's a reason for that. It's because you're squaring the numerator, and the numerator is always positive. It's positive here, positive here, positive here. It's going to be positive here. Okay. Signs of your denominator didn't change between here and here. Only the sign of your x minus 2 changed. But since x minus 2 is being squared, that didn't make any difference. So now you have two consecutive intervals where you have a solution. Okay, then. As for infinity, I'm not going to write out all the details. So let x be a trillion. Okay. So this is going to come out positive over positive, positive, which is positive. And now your solution is what? It's where this is negative because this is less than 0, right? The solution is the interval that with 3, we'll leave it, negative 3, 2, union 2, 4. Okay. So everything between negative 3 and 4 except 2, because of course at 2, this thing's equal to 0. It's not less than 0. Hopefully that makes some sense.